Now let's look at the expected value in standard error for means and percents. So we've already seen expected value and standard error in this series. We looked at them for binomial random variables. We looked at them in general for discrete random variables. But now that we're talking about polls and surveys, it makes sense to look at them for averages and means. We might want to know what's the expected value of the percent of people in the US who have gone to college. So these formulas are very straightforward, and as long as we have a random sample, we can easily use them. So for means, the expected value of the sample mean is just the population mean. So that is represented as mu, and a lot of times we don't know the population mean, so we can estimate it from the sample mean. The standard error is actually the standard deviation divided by the square root of n. And then for percents, we have the exact same formulas. You just want to multiply by 100 to get your answers in percent form. And this is if you want your units to be on a scale from 0 to 100%. So let's go ahead and do an example. It says we're going to talk about inference, which means drawing conclusions about the population from what's known about the sample. And before I do that, I do have this formula up here for the standard deviation of a population, and that is going to come into play in the example. So I'm going to dive into that as soon as it comes into play. So our first puzzle is about percents, and we're going to see how random variables and surveys or polls are related. So it says in February of 2019, a CNN poll of 1,011 adults nationwide asked the following question. So I'm going to circle this 1,011. That's how many people were in my sample. The sample size is often represented in statistics as the lowercase letter n. And then this is the population, adults nationwide. So I'm going to label that as my population. The question was, do you think the government should provide a national health insurance program for all Americans, even if this would require higher taxes? So this was a question they wanted to know the answer to. CNN really wanted to know what all US adults think of this question, but they didn't ask all US adults. Instead, they asked a random sample of 1,011 people. I know that because it says the adults were chosen as a simple random sample. And in the sample, we got a sample percent of 54%. So part A says to estimate the percentage of all American adults who would favor the National Health Insurance Program. And the nice thing is this is just asking for the expected value of the percent, and that is just the percent of American adults who would favor the National Health Insurance Program. And we don't know that, but we can estimate it with what we got in our sample, which is 54%. So this is super straightforward. Our expected value is just 54% because we did that nice random sample. And then part B says, obviously our best estimate is going to be the sample percent as we saw, but give or take what amount, because that is just an estimate. There is going to be this idea of error. So it says, what's the standard error of the sample percentage? And the standard error is just going to be, if I look back up at my formula, the standard error is the standard deviation of the population divided by the square root of n times 100%, because I do want this to be in percent form since 54%, that's how I have it. So the standard deviation of the population, we don't know. That wasn't given to us in the problem. But I do have this formula up at the top of the page. And it says we can calculate the SD of a population with yeses and nos. And this was a yes or no question, do you favor or not? Where P is the proportion of ones in the population and 1 minus P is the proportion of zeros. So this formula is really nice. The SD of the population is just the square root of P times 1 minus P. And so I can calculate that. My P, the probability or the proportion of ones is just 54%. And then the proportion of zeros would be 100 minus 54, which would be 0.46. So WAF has Python as a calculator, and he is going to let me know what the standard deviation of the population is estimated to be.
So the standard deviation is 0.498.
0.498. And so I can just go ahead and plug that in. I have 0.498 divided by the square root of n. We said n earlier was 1,011, and then times 100%. And again, Wade, what do I get for my standard error?
So I have 0.01566, then I got to multiply that by 100%. So are you here multiplying it by 100 and then adding a percent sign?
Yes.
So I'm going to multiply by 100 here on Python, and you're just going to leave the percent sign there.
Yep.
So that's going to be 1.56%.
1.56%. So basically what this means, why did I even care about the expected value in standard error? Well, now I have an idea, because I did this nice random sample, I have an idea of what all US adults would say about this question. I estimate that 54% of American adults would say they favor having this national health insurance program, give or take about 1.56%. So that's just the start of looking at expected value and standard error for polls and surveys, and we're going to dive into this even more as we go throughout this series.